Okay, welcome back to my channel, everyone. Today we're going to be implementing the let and constant declarations for our language. So let's get started. First thing I want to mention is currently we only can declare variables by setting hard-coded values up here. So today what we want to be able to do is implement the let and const expressions for language. So we can talk about what defines a constant versus a assignable variable at runtime, as well as how we actually parse an expression like this or this. So let's actually get started by going over to the lexer and adding a new const keyword. So currently we have the let and const keywords. Let's now go ahead and make sure that we add let is of type token type let, and const is of type token type const, like so. Okay, so once we've finished with that inside of our lexer, we have to just make sure we have the equals token, and we're actually done with our lexer. Let's now head on over to the AST and define a new node. So it's going to be a statement, but before I'm going to separate these into expressions and statements, like so. So it just makes it a little bit cleaner. Then we're going to say we also have a new type called variable declaration, like so. It's a variable declaration statement. I'm just going to get rid of the word statement, but there we go. So we need to define this new type. So let's actually copy this real quick. We're going to have, I'm just going to get rid of the comment for now. And what we're going to do is we're going to say this is of type variable declaration, like so. And so we're going to change this to, again, be var declaration. I'm also going to change it so they all kind of match. Var declaration. And what we want is we want this to have 3 different fields. Let's implement the constant field, which is going to be a Boolean. So this is going to tell us whether or not this is a constant expression. Then we want to keep track of the identifier, right? So this is going to be a string. And then we want to keep track of the value that's used. So let's just do value is equal to of type expr, like so. Now, one thing you'll notice is I did use a question mark. For those of you who are unfamiliar with TypeScript, this means that this could be this or undefined, right? If we do something along the lines of let x like so, and then a semicolon, we assume that x is undefined. So we want to say that the value could also be undefined. So now let's actually go ahead and implement this inside of our parser. So inside of the parser, currently all we've ever done is implement expressions, right? So we can look, we parse a statement, and we immediately go down to parse expr. However, what we want to do is we actually want to switch. Similarly, we want to switch on our parse expression. So let's do the case is going to be, not case. So we're going to do, what is it? At this dot at, and this is going to return the currently available token, and we're going to do dot type. And there we go. So what we want to do is we'll have the default case continue what we were doing before, where we just called this dot parse expr and bubble it up. So we're going to return this dot parse expr, like so. But we also want to handle the case of, say, something like token type dot, and let's say we want to handle the case of a let expression, like so, as well as the case of token type dot const, because those are both going to be a variable declaration statement. So we're just going to come down here and do return this dot parse var declaration, like so. Now let's actually go ahead and create this function. So we're going to do declare method parse variable declaration right here. Okay, so now let's actually go ahead and implement this method. So a variable declaration, there's 2 ways that we can kind of think about it. It has the const or the let keyword, and then that'll be followed by the identifier. So the identifier, and then we have 2 options. We either have an equal or a semicolon, right? So that's one option. This would return a you would expect only let to be available here, right? Let ident like so is going to be a non-constant expression. And then we also have the other choice, right? Let or const ident an equal token, and then we expect to have an expr and then a semicolon, like so. So these are the two kind of things we need to look for. So let's actually start by handling them like so. So the first things first is we need to know whether we found a let's token or whether we found a constant token. So what I'm going to do is I'm going to do const is, we're just going to call it is constant is going to be equal to, and we're going to do eat. So we're going to do this dot eat, which is going to return the current token, but it's also going to advance forward. Dot type is equal to, and we're going to do token type dot constant. Right, so what this is going to do is it's going to say, hey, if the current token before we advance is a constant, after we advance, is this a constant or not? So now we'll know whether we just found the let's or whether we found the constant token. Okay, so now that we have that, let's actually now get the identifier name. So const identifier is going to be equal to this dot expect. We're going to expect a token type dot identifier, right? And then the error is going to be expected identifier name following let's or const keywords, right? So we want to basically throw this error message if this is not an identifier. And then what we're going to do is we're going to get dot value to actually get the hardcore string under the hood. So there we go. Now we already have the constants and we have the identifier, which means we've already handled 2/3 of this case right here. So let's check if there's a semicolon, so that way we know if we need to just break out like so. So what we're going to do is we're going to check if this dot at type is equal to token type dot semicolon. Oh, and I actually have to implement the semicolon type inside of the Elixir. So let me just, let's go ahead and actually implement this type right here. So inside of the Elixir, we need to be able to handle a type. So we have this equals type. Let's also handle semicolon like so, which means we need to actually check for it inside of our searching like here. So what I'm going to do is right by the equals, we're going to check for semicolon like here, and then we're going to do its token type semicolon like so. Okay, so now we can check for our semicolon, and what we want to do is we just want to basically do a variable declaration like so. So the first things we're going to want to do is we know we found a semicolon, but we want to make sure they didn't use the const keyword. They only allow let keywords. So we're going to do if this dot at dot type, or sorry, not this dot at, if this is constant, right? We want to check if we already found a constant, but we're at a semicolon. This isn't allowed. You can't just say let ident undefined kind of like this. You have to give it a value if it's constant. So if that's the case, what we're going to do is we're going to throw cannot must, we'll just say must assign value to constant expression no value provided, right? Obviously, you'll want to do better with your error messaging. You can also have in the token the location of the error, so that way this is a lot cleaner. But we're checking for the token, and if we're not at a constant, we're going to throw. And what we're going to do is we're just going to return a variable declaration type. So we're going to do return as variable declaration. And what we're going to do is we're going to say the kinds is variable declaration, right? The identifier is going to be our identifier. Then we're going to have our constant is equal to is constant, which we already know is going to be false at this time, so we could just write false. And then we want to say that, yeah, we don't really have a value, right? So we're just going to do value is equal to undefined, like so. And we also don't need to pass the value since it's inherent that it's undefined if you don't pass it. So now we know at this point in time, we have already checked for a semicolon, right? We've already checked for it. What we need to do is we need to return the value, and we need to advance, right? So we need to actually do this dot eat expect semicolon. There we go. So now we're eating the token, and we're able to return this up. Now we want to actually check for the token type equals. So we're going to do this dot expect token type dot equals, right? Expected equals token identifier in var declaration, like so. So we're going to expect the equal token. And now, if we recall our rule, we want to, we've already parsed the let const, the identifier, the equals. Now we want to handle the expression and the following trailing semicolon. So what we're going to do is we are going to do const declaration is going to be equal to, we're going to have this as a variable declaration, like so. And what we're going to want to do is say, again, the kinds is variable declaration. The value is going to be this dot parse expression. And the is constant is going to be is constant, like so. So now we have our new variable declaration type. And again, if we think about it, right, we've parsed the equals token, therefore we expect an expression. So the value is going to be parsing an expression, which will allow any complex expression, right, on the right-hand side. And we'll also pass if it's constant. Now we have this declaration, but depending on if you want to force your language to allow semicolons for declarations like I do, what we're going to do is we're just going to do this dot expect token type dot semicolon variable declaration statements must end with semicolon. Right, and then now all we have to do is return the declaration. So let's take one quick look, right? We check if we're constant by parsing past the let and const variable. We get our identifier, expecting it to be a string, and we actually retrieve the string value. Then we check if we're at a semicolon. If we are at a semicolon and we're not constant, then we can return a variable declaration. Then we expect an equal token, followed by an expression and a semicolon. So we actually have implemented our variable declaration. Let's now go ahead and give this a shot. So inside of the REPL, let's go ahead and actually give this a quick run. So let's just do dino run -a main.ts. So we have our REPL. Let's try doing something like let's, like so. And sure enough, we get parser error, expected identifier name following let or const keywords. And then we can see we instead received an file expecting the lets. Let's rerun this and say let's x semicolon. And perfect. We get this AST node has not yet been set up for interpretation, right? This is on the interpreter side. But we can see the identifier is x as expected and constant is false. Let's do let x is equal to 45 divided by 2. And, oh, I didn't actually start up the REPL. Let's x equals 45 divided by 2. And sure enough, this is what our thing is, right? This node is not set up. It's a token type of variable declaration. The value is of type binary expression, where we have a left and a right operand, and the constant's false. And let's just double check and make sure that const x, we can't do this. And sure enough, we get error, must assign to value, none provided. Beautiful. So now that we have this all set up, let's actually now go ahead and implement inside of the interpreter our variable declarations. So let's get started. What I'm going to do is I'm going to open up the runtime folder now, and I'm going to have to implement the interpreter. So inside of the interpreter, we can see where we were getting our errors. right? We could see, where is it? Right here, right? We never actually checked for a case of handle statements. And what we're going to do is we're just going to do case of variable declaration, right? And what we want to do is return eval, and we're going to do var variable declaration, like so. And what we're going to do is we're going to do AST node as a variable declaration, and then we're going to pass in our current environments. Now I'm also going to use the missing function declaration, like so. And now let's actually go ahead and implement this. One thing I'm going to do is inside of the runtime folder, I think it's now about time to create a little bit of separation between our types. So I'm going to create a folder for the eval stuff, eval, like so, and then I'm going to just move and add a new type in, or a new file in here, sorry. That's going to be eval statements.ts, and we can actually get rid of the eval in front, and let's also create one for .ts, so that we can kind of have two sections for our statements and our expressions. Okay, so what I'm going to do is I'm going to move the eval program into the statements, right? So we're going to move eval program in here, and then I'm going to add all the missing imports, .ts, and .ts. Beautiful. So now we have this, and we're going to export this function. Exports function, eval program. Perfect. So now we no longer have that in here. Then let's change it so we can actually get all of our numeric expressions, our binary expression, our identifier, like so, all in their own type right here. So now let's add this to the expressions. I'm going to do, this is not working. That's why. We're going to import all of the things we're missing. Exports function. There we go. Add all missing values. We're going to do .ts, and .ts. And there we go. So now we just need to export these functions for use, as well as right here. There we go. So now we've separated our expressions and our statements. So we can get rid of, add this to the statement file. This will be in here. Again, we're going to export function, add the variable declaration, updates, there we go. And now we just need to import all of our functions. So add all missing, not function declarations, no. Add the imports, add all missing, I'll just add to type eval and import them all. So we're going to do imports, eval program, eval, let's just do .ts. So we're going to eval program. We're going to bring in eval variable declaration. Then we also want to import eval, identifier from ./eval/expressions. So eval identifier, did I not change spelling? Oh, yes. So we need eval identifier, eval binary, eval numeric, like so. And there we go. Now we actually have all of the things we need. And we actually don't need to export eval numeric, right? This function's used internally, like so. Okay, so we have everything we need. Now let's go ahead and implement our variable declaration statements. So inside of the statements, we have our variable declaration. The declaration is going to be, I'm just going to call it declaration, and the current environment, right? So what we want to do is for a variable declaration, What we want to do is we actually want to assign it into our environment, right? We have this declare variable function already set up in the environment. So we can actually now go ahead and just use this. So we can do env dot declare variable. It takes in a declaration dot identifier, declaration dot value, like so. Now one thing you'll notice is this value may be undefined, so I'm going to just call it value, and we're going to do const value is equal to declaration dot value, and we're going to do a ternary expression. If the value exists, we're just going to do declaration dot value. Else, we're just going to do make null, like so. Okay, so and we need to parse this, right? So we need to do eval of this with the current environment, like so. So now I'm just going to eval weights, like so. And there we go. This is what we expect to have, right? If we wanted to parse this value, we need it to be as a runtime value. So we check, hey, does the value exist? This is an undefined, or it's an expression. If it's an expression, we evaluate it. If it's not, right, we just parse it as null already, and we can declare the variable like so. And then now we actually just have to do return like so, because this will just return the value that we just declared. So that's really awesome, right? Now we're able to declare variables. So let's actually give this a quick test and see if it works, and then we'll implement the constants, since that's the only thing not implemented right now. So we're just going to do deno run, right? We're going to do let x is equal to 45. Cool, we have x, and I'm going to do x plus 5, and we expect to get let x equal 45. Yes. So one thing you'll notice is x is a value of 100. We can do let f equals 45 plus x, and cannot declare variable undefined. It is already defined. Error, cannot declare variable undefined, as it is already defined. So what we see here is it looks like our identifier is having an issue. So let's try to debug this. Cannot declare if this dot variables dot has var name, as it is already defined. Var name, okay. So here we're seeing that we return our declare variable, and we have our declaration dot identifier. Let's actually validate that this is what we expect it to be, and go in here. Yeah, let's just validate this and check that var name as well as the value is sets, like so. So we're going to just rerun this. And we can see that x was declared, true was declared, null was declared. And let's try let f is equal to 45. We get undefined, and then we get type number. So that is definitely an issue. So let's see why this is coming out undefined. Let's check inside of here. Our declaration should contain the value of type string, so clearly that's not the case. Let's look into the parser and actually validate that that's what's happening. So inside of, not the runtime folder, but the parser.ts file, what we want to do is we want to validate that this exists. So we're going to go up to our parse statement right here. We have case const. We're going to do parse variable declaration. We're going to do is constant is equal to that type. Beautiful. Then we're going to expect to get an identifier. This should be of type string. Cool. Then what we want to do is, we have our identifier in here. And, that's the issue, right? We have a kind, we have a value, and we have a constant, but we do not actually pass the identifier, like so. So that is a bit annoying. Okay, now we can actually go ahead let's just do a click clear. Dinner run, and we can do let x, or we already have x defined, but let's try it. Let x equals 45. Uncaught, cannot declare variable x as it's already defined. Beautiful. So now let's do let y is equal to, if x is 100, we'll do 200. Perfect. So now we should be able to say y divided by x, and we get 2, which is obviously correct. We can do x plus y minus x plus y minus 50, and we get 250 as expected, right? So we can see that we can use these variables. However, say we want to actually add this to be a constant. Let's go ahead and just quickly do this. So const z is equal to 300. We have z. And in the next episode, we'll implement this kind of thing where we can do this. However, currently we can't do that. But let's actually just add support for constants right now so we don't have to worry about it in the next episode. So what we want to do, right, we have it so inside of the AST node for a variable declaration, we keep track if it's constant. But we're not actually using this when defining the variable. So let's go into our eval variable declaration. We would probably want to, inside declare variable, pass in whether or not this is a constant. So we're going to do declaration.constant right here. And we want to pass this in to our declare variable function like so. So let's actually now go ahead and modify our declare variable function to accept a boolean. So we're going to pass in constant, which is a boolean, like so. Beautiful. So now we accept this constant, right? We're not getting an error there. And what we want to do is we want to keep track of what type of value is. Now, one thing you could do is you could store, instead of storing a string to a runtime value, you could store a string to some other data type that contains that. Or what I would rather do is just have a map. So we're going to have constants is going to be a set, sorry, not a map, of strings. And what this is going to contain, sorry, I didn't mean to do that, is what this is going to contain is just a set of strings. If it's in here, it's a constant. So we're going to do this dot constants is equal to new sets like so. And now we can actually declare constant types as in. So that's beautiful. So now what we're going to do is we're going to actually check when we declare a variable, we're going to set the value, right? And if it's a constant, we're also going to do if this dot if const ints, what we're going to do is we're going to do this dot constants dot add, and we're going to do var name, like so. And this is just going to double check that we've added it to our constants. Inside of assignment, what we're going to want to do is we're going to check if this environment that contains it contains that constant reference. So let's go ahead and do that. We're going to do if env.constants.has var name. Then we know at this moment in time, right, we cannot do a constant. There we go. So what we're going to want to do is we're going to check if the environment that our variable name is located in when we're assigning is a constant, then we want to throw an error. So throw, and we're going to do cannot re to variable var name as it was constant. And there we go. So that's awesome, right? Now we can actually define constants and make sure that we can't reassign to them. Obviously, we don't need to do anything for the lookup as well as resolve. So that's awesome. Now we can actually try testing this out, but the issue is since we haven't implemented assignment expressions, we can't see anything. So in the next episode, what we're going to do is we're going to implement support for something like let's v equals 45, and then we'll be able to do something like v is equal to x divided by 2, like that. Currently it isn't supported, but in the next episode it will be. Okay, so I know this was a long episode, but I guess leave a comment down below if you'd like me to kind of go through these a little bit quicker. But yeah, I hope you found this video useful. If you did, please like, comment, subscribe, share with your friends, all the good stuff. Please join our community Discord server if you haven't already. and I'll talk to you guys in the next video. Peace.